Hello and welcome everyone to creating and managing complex event responses. My name is Mark Henry. I'm a senior engineer with Opmantek's North American office located out of Charlotte, North Carolina. Today's webinar is a subject that's very near and dear to my heart and one that's really exciting to me. In my history, I've been both a programmer, a programming manager, a network engineer, and even an MCSE. And some of the things that I've learned over those years is that no matter how many engineers you have on staff, there's never enough time, never enough resources, never enough opportunity to do all of the troubleshooting and remediation that you'd like to be able to do in response to the events that occur across your network, across your applications, and how those impact your usability and how users kind of see and feel about the IT department as a whole. So today, if you're attending today's session live, we will be sending you a follow-up email with a link to the recording. If you have any questions, please raise them depending on which version of the GoToWebinar control panel you have. You can either raise them through the questions panel or the chat window. Again, it depends on what your operating system is and what version of the GoToWebinar chat, GoToWebinar client you have running, rather. If you leave today's webinar early, or if you go through to the end, you'll be presented with a very short exit survey. Please take a moment, answer the 3 questions. We do use that information to drive future subject matter and to also make sure that the content is relevant to everyone who's here. So today's topics, we're really going to focus in today on the concept of a complex adaptive system, or CAS. We're going to talk about what a CAS system is, how to implement it with Opmantek solutions, methods for designing kind of an overall event escalation system, how to create troubleshooting scripts, including collecting device configuration information. We're going to talk about how to build notification routines to handle after-hours, weekend vacations, and we're really going to talk about how to expand the entire system using opConfig, leveraging various APIs, including the opEvents API, the opConfig API, and NMVS itself, to really build a event response system which is automated, intelligent, and capable of being expanded and built upon very easily as your implementation of Opmantek's network monitoring solutions grow. I always like to bring these workshops back to the Gartner IT Service Management Maturity Model. The biggest concepts here really are that when you start being able to automate event response, and I'm not just talking about collecting troubleshooting information, although that is a core piece, but actually taking proactive response to an event, what you're doing is you're really moving your organization up solidly into a level 2 and a level 3, and you're starting to level or edge into a level 4, or managing IT as a business. And what that does is the higher up in these levels that you become, you're increasing both your internal performance and, of course, the value of the IT department into the entire organization, right? And whether that's you're acting as a managed service provider, or if you're an ISP, maybe you're managing clients' devices, maybe you're just managing your lines of business. It's all really the same thing. The higher up, the further you move into these various levels within the maturity model, the more value you're adding to the organization and the more value you're adding to your customers, whether they're internal lines of business or external customers. So today, we're really going to be focusing on opEvents, which is one of Opmantek's open source commercial solutions. opEvents, of course, is an event management solution which sits on top of NMVS, which is Opmantek's fault and performance solution, which is open source. We'll also be touching on using opConfig as well, which allows us to pull device configurations using CLI or using other types of scripts, compare those configurations, generate events and alerts, and also to push device configurations back out to those devices. So a whole plethora of useful references for you. For those of you who are quickly scratching down these URLs or who are doing screen captures, if you're here live with me today, and it looks like we've got about 80 people online, that's fantastic. Please check the GoToWebinar handouts panel. You can get a PDF version of today's presentation and download it and follow along there if you want to. For those of you who are watching this on the Opmantek YouTube channel, please go to opmantek.com. That's opmantek.com. Select Learn in the top menu option and look for this webinar. We'll have a copy of the PDF there that you can download. But we do have detailed references, and I'll also include these references on each page within the both the slideshow and, of course, on the PDF as well. In addition to the wiki references or documentation, you can, of course, come to the community questions board, community.opmantek.com/questions, and ask any questions you have. If you are a supported customer, please reach out to support@opmantek.com. That sends a flash email to all engineers worldwide, and so someone can get back to you quickly in regards to your question. If you're interested in trialing or doing a proof of concept on any of the products we talked about today, please feel free to reach out to usa@opmantek.com, and our sales team will be happy to do an introduction to your local account manager, regardless of where you are globally. This presentation does build on a series of past webinars. So if you're coming into this, this concept new and fresh to Opmantek Solutions, I do recommend you watch these 4 webinars first. These will absolutely help make lay a good foundation and help make today's webinar make a whole lot more sense to you. So let me give you an example of a kind of a common event response that we often hear. We do implementation as part of our professional services packages with clients many times a year, and this is a kind of a mashup of kind of an example event response. One of the first things we do is just get our clients together in a room and say, for an example event, let's say node reset or node down, what are the steps? What would your engineers do? What do they see? How do they respond? What emails do they send? What phone calls do they make? What troubleshooting do they do? And so this was an example of what a couple of different companies came back and said, this is what we do. So generally, one of the first things we heard is that it will often take a minimum of somewhere between 30 and 60 minutes before an engineer is available to even start taking response. So the event has occurred and it's been ongoing now. It hasn't cleared itself. It's been ongoing now for at least 30 minutes, maybe as much as 60, before someone even starts moving to the second bullet point. In many cases, the engineer would then try to determine a priority for that event. Sometimes if they're an ISP or an MSP, how many affected customers are they? Are they a VIP? What time of the day, what day of the week is it? And they would set a priority based on a set of rules or even just on an arbitrary, this is what I think is a good priority for this. Oftentimes they'll send out some kind of an outage email. They might create a help desk ticket. Then they'll start doing some kind of troubleshooting. They might ping the device, run an MTR, try to determine if there's been a change in routing to or from the device. They might collect some kind of device configurations if it's a networking type device. If the event is service related, so for example, if there's a problem with BGP, they might want to restart the service. They might try to restart the service on the device. If the event doesn't clear after restarting the service, they might restart the device. And of course, both of those steps are kind of assuming that the device is, of course, responding to the command line and that the engineer in question has the both permissions and credentials to be able to log into that device. For many managed service providers, they might update their website for outage areas and affected users, and then they might dispatch field services, whether it's via an email or a phone call or an API. So when you start talking about the concept of automation, there are many different patterns, programming patterns that can be taken into account, ways of putting together automation. One of them that we're going to talk about, we're really going to focus on today, is a complex adaptive system. And this is really a very advanced topic. It's an advanced concept. Again, please review those 4 webinars I mentioned earlier. They do start small. With basic concepts, you should absorb those first before you move on and try to apply the concept of a complex adaptive system. The idea here, though, is that with a CAD solution, you have many components or agents, and they all interact and adapt, or they learn how to talk together and how to work together to create a sum of their total that is much greater than any of their individual impacts on the issue. So, for example, agents interact dynamically. They talk to each other as they need to, but they are often ignorant of the system as a whole. These interactions can be really rich, so they can pass a lot of information back and forth, and they may affect or be affected by other agents in the system. So one agent may make a decision or come to a conclusion that another agent needs to be invoked or called, and it may pass information into it, and that agent may then do something with that may then affect the first agent that called it. These interactions are generally nonlinear. They can feed back on themselves. They can create reciprocal or responsive actions as well. In many cases, the overall behavior of the system cannot be predicted by the behavior of an individual agent, because again, each of these pieces are working on their own, but they're also communicating with each other. So if this is seeming a little perhaps alien to you or odd, it's because in many cases, you could look at examples of termite nests, for example, as a great example of a complex adaptive system. Each termite acts independently of every other termite, and yet they work together as a community to create a nest which keeps them both warm throughout the nights and cool throughout the day, that provides methods for reproduction, for managing and raising their children, and also for harvesting food, bringing it back, and storing the food and water for long periods of drought. So again, each agent in that example of a termite nest, or each termite itself, is an agent working independently and not under some masterful supervision or management structure. And yet they all work together to create a cohesive community and society. So thinking back to that example that I gave earlier, that list of steps that were being done, and in the example I gave, those steps were actually being done manually by an individual engineer who was walking through kind of a checklist for every single event that's happening and following and doing every piece that's in there. The challenge they would often run into is that by the time they would get to their troubleshooting steps, the actual data, the actual performance information that they would want to collect has now gone, right? The event is cleared, whatever bottleneck had happened on the network, whatever impact had happened, had cleared itself, and they could no longer capture that information because it's passed. With a complex adaptive system, and kind of translating the idea of a CAS response into Opmantek's network monitoring solutions, we start with the dark blue line down the center of the screen. And we start with the origination of the event. And again, doesn't matter what kind of event. Let's say that it's a node down or a node reset. And then a series of checks and balances begin running. And so, for example, as time continues moving left to right, so think of this as a timeline. As time begins advancing, we get to our first check, and the system says, well, if the device in question's not currently in outage, so if it's not marked in outage, so it's not in maintenance, it's not being worked on, then run an action to determine the priority of the event, create an email to the technicians, and create a ticket using the API. So we've automated these steps, and these can all actually happen at any time along this timeline. It could actually happen at the moment of the origination of the event. You might wait 5 minutes until the next polling cycle, etc. And then there's some troubleshooting commands that are run. The system actually pings the device and runs an Nmap port scan, gathers information, and connects that to the ticket. The next thing it does is it runs a fast MTR. So it's actually running and coming up with all of the hops between the polling server and that device, and it's going to compare that and start an entire new route of escalations and logic as it moves forward But if a change in the routing, if the change in the number of hops has been noted, then it's going to follow this path. It's going to, again, adjust the priority of the device, and it may reroute traffic. Continuing on the main thought process here, if the event is service related, it might restart the service. Next, it might collect some troubleshooting configurations. And if a configuration change is detected, again, an entire new round of escalations or agents, again, could be started. So as you can see by this example, all of this is being done automatically behind the scenes. All of this is being done by the event management system in response to the event. Not only is it managing the initial event, but it's also creating and spawning off new events based on troubleshooting information that it collects. So based on that information, it's actually spawning entire new paths of logic which can interact with each other, spawn their own routes of logic and additional tests and checks, and each of these work independently of each other. So let's talk about how do we actually get to that point? How do we actually create something like that, and how does it work through Opmantek solutions? So starting with the concept of Opmantek's application flow. Using a product we call opHA for high availability, you can scale a deployment of our solutions horizontally and vertically. So you can have one layer of pollers or collector servers, which are talking to subnets, gathering information from devices, processing things like application services, SNMP WMI, SNMP traps, syslogs. You can also take in synthetic events that are being pushed into the system as well. It's processing all that information, and it's handling it here locally at that event polar level using opEvents. And then based on a set of rules, it can move those events from opEvents on the polar and send them to the master, which would be the level of activity that someone, say, at a NOC site might be watching. Now, you don't have to employ opHA to scale. If you don't have the need to exceed, let's say, somewhere around 2,500 or 3,000 devices, you can actually do everything with just a polling server that also acts as a master. That's absolutely fine, no problem at all. It's just an option if you do want to be able to scale out or up. So opEvents replaces NMVS's built-in escalation system. So again, the core fault and performance system is NMVS. It is free and open source, and it's designed specifically for smaller businesses to be able to deploy and manage small business networks, LANs, or very, very small WANs without having to scale and without having to do a lot of really much more in the way of escalation other than notifying someone that something happened. When you want to get into fault management and really operational automation, when you really want to be able to respond to events that are coming into the system and do something proactive about it, you upgrade to Opmantek's opEvent solution. And what that really does is it gives you the capability to whitelist and blacklist events. It does correlation, deduplication. It'll talk about event storms, event flaps, and of course, it will handle event responses. There's a lot of processing that opEvents can do for you. It starts with applying an archive list, then a blacklist, a whitelist. It'll do correlations, which we'll talk about in a minute. It'll deduplicate events. It'll assign to event priorities. It'll conduct actions, and that's the section we're really going to focus on today. And then it will do escalations, which we're going to touch on as well. So from a kind of a basic standpoint, if you were to employ opEvents for the first time, we would start with what's called basic event automation. You take a look at your top network events that you respond to frequently, daily, weekly, or monthly. Write down the list of steps for each of those events. What do the engineers do? What do they do manually? What do they do automated? And then determine how you can automate those steps in opEvents, and then create opEvent actions to respond to those. So again, That's kind of that's level 1. What we want to get to with a CAD solution is really at a level 3 or 4. So we're going to be stepping up through several levels of iteration. So let's talk about a complex adaptive system and what is that comprised of. So we talked about the concept earlier that a complex adaptive system is made up of agents or individual components, right? And so you can think of those components being like Lego bricks. There are many different sizes of bricks. They come in different shapes, different colors. Each of those pieces, each of those Lego bricks, again, using that as an analogy, is a different agent or component of the Lego brick building system. When it comes to building a complex adaptive solution or system, each of the pieces within opEvents, opConfig, NMVS, and even opTrends, if you want to expand that far, gives you pieces or components that can become bricks that you will build on to create simple responses. Those responses will then be threaded together to create very, very complex solutions that can adapt and grow depending on what's happening across your network. So the first piece of those solutions is opEvents correlations. It allows you to create synthetic events from base events. Then you have event policies. These are simple if-then rules that fire off scripts and escalations. You have opEvents escalations, which create complex time-driven paths for activities. You have scripts, which create and log, return the results of information, so you can execute bits of logic. You have the opEvents API, so you can actually raise new events based on the output of comparisons and calculations. You have opConfig commands, where you can connect to devices using a CLI and execute commands, whether it's capturing information for troubleshooting. You can also expand opConfig with plugins, which give you access to device credentials and allow you to raise events. You can do configuration push with opConfig, so you can push configurations back to devices. Again, each of these options here build upon or become parts of agents which you will use in response to events. So let's look at some of these in a bit more depth and granularity. So the concept of an event correlation, and we've got an example here at the top of the slide. So 3 or more device reset events at the same location within 3 minutes will become a location power outage. And what that means is rather than having 3 events for 3 different devices, each one of them a device reset, those 3 events are now going to be pulled together and correlated into one event, a location power outage. And then that event will exist on its own until each of those 3 child events that comprised it clear. So you would really use event correlation when the response taken to the synthetic event would be different from that taken for the individual. So think about it this way. If you were to have a power outage at an entire physical client location, that power outage might take out all the devices that are there. The devices might have device resets as they reboot. You might get alarm responses from the UPS systems. You might be watching the UPSs and see that the UPSs raise an event, an alarm, that they're now in power drain mode, that they're providing power, that input power is off for that UPS. And so you might take those individual events, and rather than dealing with them individually, you might say, gee, if I lost power to one UPS, it might be a faulty UPS. But if I lose power to every UPS in every rack in my data center, I know that it's a bigger problem. I know that we've lost power at that physical site. And so the priority for that event, that location power outage, you might want to make that a 10 rather than a 7 for an individual UPS loss. So there's a lot of other things that you might do as well. For a location power outage, you might want to wake up the ops boss with an email or a phone call, notify the people who do the maintenance on the on-site generator, make sure that the generator is running, make sure someone goes and checks the fuel level on the generator, that it's responding. So there's a lot of different things that you might do from a correlated event that you wouldn't necessarily do from an individual event that makes up it. An important concept with a correlated event is that the child event processing is suppressed. So once those 3 events, or 3 or more, for example, are correlated into that synthetic location power outage event, the individual child event processing is stopped. So we're not going to continue processing the individual events. We're going to be managing that location power outage. Another component of creating a complex adaptive system is what's called an event policy. So event policies are located in the EventActions.nmis file. It's a simple if-then statement. They are kind of waterfalls of statements that process down from the top of the page to the bottom of the page. They process in order, and it's important to understand that policies are called just once for an event. So if an event is going into opEvents and being processed, and it comes in as a low-level warning event and stays open for a lot of time, and let's say that it's a rising temperature. So it may come in as a low-level event, and as it's rising over time, as that temperature continues to rise, and it trips from a warning to a minor to a major to a critical to a failure, as it moves up through each of those kind of warning or priority levels, those event policies, those policy rules are not being re-executed. So that's an important concept to understand. You only get one pass for an event on the policy rules. So you need to keep in mind what you want to do with that information in that event over time. Now, you can do lots of things with escalations that we're going to talk about in a minute, because you can create an escalation policy that says, hey, in 2 hours, if the event is still live, increase the priority, run some stuff, notify some other people, run a script, capture some information, etc. Let's take a look here at what an event policy looks like. And now what I've done is I've actually moved over to opEvents. So let's take a look at our event actions. I'm going to open up the event actions editor. And I'm just going to increase my browser size so this is a little easier for you to see. So at the top of the event actions file is the policy section. And then you begin with this waterfall of policies, which are comprised of very simple, straightforward if-then statements. Now notice that there are no if-then-else statements. There are no else options that are here. So each individual if statement is analyzed and determined on its own. If you have multiple options in your if statement, so if this and that, so for example, node.role equals core, and event.event contains the word down. So both of these have to be true in order for the if statement to evaluate as true and the then statement to run. You can also combine multiple responses, multiple thens. So for example, in line 100 here, you'll see that we do script.ping node and script.traceroute node. So we're doing multiple different scripts that we're calling from this one policy. In addition to calling scripts, you'll notice we're also doing things like adjusting event priorities. And if we look further enough through here, we'll find an escalation word. So excellent, here's an example, escalate, troubleshooting, escalation. So this one starts an escalation policy. So escalation policies are all about creating something that has some longevity, that is time-based or time-controlled, that allows you to take actions or responses over time. It's important to note that an escalation policy only stays active while the policy rule that called it is in effect. So if the event that created the policy rule is acknowledged manually, is acknowledged automatically because the event clears. There's an opEvent there's a clearing event, again, or someone or a script acknowledges that event, then the policy rule is canceled or closed, and the escalation stops wherever it is. So again, policies run once for each event, but escalations can run over time. So in many cases, what you do is you start your policies. Your policies call one or more escalations based on comparison rules. If the event is this, call that escalation. If the event is this priority, call that escalation. If the event belongs to, or the device in question that caused the event belongs to a VIP customer, call escalate, VIP customers. So you can have multiple escalations running at one time. The only thing you can't do is you cannot call one escalation from inside another escalation. But what you could do is you could call a script from an escalation, and that script could then call another escalation. That's legal. So event scripts. Event scripts are all about doing some kind of a complex action, like collecting troubleshooting information, executing external scripts, doing something that you want to be able to really drive the collection of information from. And so if I scroll down, scripts are all stored in the script section. And so, for example, you can see here that we're running, in this example, we have a script called nmap services. We are calling the nmap program on our local polling server. We're passing it a series of arguments, -sv, node.host, so we're passing it a couple of different arguments that are being passed to it. And we've told the system to save the output, save the returned results of that. Now we can actually use that saved information to drive other scripts, drive decision making, generate other events. We might call an external script if we wanted to. So for example, here's one where we're actually calling OpenAudits discovery, and we're going to audit the device in question and update the device's audit in OpenAudit. So you can call anything that you can execute from a Linux command line, whether it's a Linux command, calling a program that's installed, creating a script in Bash, in PHP, in Perl, in Ruby, in Python, Go if you wanted to. Anything that you could execute from your Linux command line, you can call as a script from inside opEvents, and then the sky's the limit. We've had clients who have written scripts that change the polling frequency on a device, that change configurations on the device, that restart services, that restart the device itself, that write out or read from an external API, that write to other databases, that push data out into BI solutions. So again, the sky is the limit when it comes to an opEvent script. The idea here is to keep the scripts small, targeted, and very tight. So generally speaking, you wouldn't want to call out to a script that does 10 or 15 different things, affects multiple other devices. Instead, what you would do is create small modules and then connect those together. Another piece is the opEvents API. So the opEvents API is a RESTful API. The concept here is, again, you might use something like an opEvent script. You might create an opEvent script that generates that uses the opEvents API to generate a new and totally separate event. That event would then be processed by the event actions, by its own policies. You would have its own correlation rules. It would have its own memory space to operate within, and it would have all of its own additional actions that could be taken. So for example, you might have an event that happens on your network. You gather information from a device, and based on the information you collect from that device, you may have a script which then says, gee, if my temperature is over 100 degrees, then what I want to be able to do is I want to create a separate event for a a hot data center, right? So you might have a temperature sensor in your data center, and it's showing a high temperature. And what you want to do is you want to create a new synthetic event that has a life of its own, that has a lifespan of its own, that's maybe not being created from a correlated event, because you might not have multiple temperature sensors, but you want to create its own event completely separate from the event chain that created it, and has a life of its own, and that itself might have its own escalation policies, escalation rules that you're going to carry on its own. All right. So what other parts or components do we have available to us to help build a CAS system? So we have the concept in opConfig of being able to execute CLI commands on a device. It's what's called an opConfig command. And what you do with a command is generally you execute CLI commands on that device. So you connect via SSH or Telnet, you execute those CLI commands, and the results of those commands come back to opConfig. Now, many people say, well, gee, couldn't I just do that with a script and call that from opEvents? You could, but opConfig has a couple of benefits over opEvents. opConfig has its own credentials vault within it with all of your credentials for your devices. So your SSH credentials for those devices are stored in there, and opConfig has access to those encrypted credentials. So you can actually pull those credentials to be able to, again, SSH or Telnet to the device, execute your CLI commands, execute specific commands based on the type of device or even the type of command set. So you might have different commands for hourly collection, daily collection, troubleshooting, troubleshooting BGP. You may also use what are called opConfig plugins to expand beyond the idea of using the CLI and SSH or Telnet. You might want to reach out to a device and pull an XML configuration file from it, parse that configuration file, store the results of that file, and then compare that to the previous version and raise events for changes. So these are all features that you get in opConfig that you don't necessarily have access to in opEvents. So opConfigs, especially when it comes to opConfig plugins, they really have two different classes. So you can do collection plugins that collect data from devices, and then you can do processing plugins that filter and transform the data that was collected. So you can collect information, right? You can run pretty much any command, especially commands that require, again, credential sets to that device, and you can pass those credentials to the device. You can also run those commands locally on that device without having to SSH to it, right? So again, because you have the SSH credentials to the device stored in the opConfig system that you don't have access to in opEvents, if you wanted to do, let's say, run a df-h on the device, you could do that with an opConfig plugin, and because opConfig has the SSH credentials to the device, you could remote into the device, and you'd say, if the device is a type Linux, then I want to SSH to the device and execute df-h and return and save that results back to opConfig. So think about the power of that for a minute. You might do something like an MTR and do it through opConfig and store the MTR back in opConfig, and opConfig would automatically process the results of that MTR and compare it with the previous MTR results, and then it could raise its own events based on changes in those commands. So if you're pathing, right, if the number of hops between devices or if the paths used to generate those hops from the polling server to that device change, you could raise an event for that. And so you could create a whole new event chain but just by pulling that config and raising an event from it. You can also push event configurations to devices. This page actually shows an example at the top of an event action policy where we are comparing a specific node. So if my node is marked as a core device, if it's a router, and if the event was node configuration change, so if the event was created by opConfig, that there's been a configuration change, we can actually run a script to reset the router configuration. And then that script is down here where we're actually calling the opEvents CLI, and we're telling it to push a config set. We're giving it the name of the config set, and we're giving it the device to push that configuration out to. So lots of different bits and pieces again. So go back to the analogy of the Lego set. So if each of these individual pieces are different types of bricks that can be put together, as you start assembling something like this example, where you have an event action policy calling an event action script, that script is reaching out through the opConfig CLI to execute a configuration push. So you have a config set that's been saved in opConfig. You're going to push back out to that device. So now you've taken several different bricks and snapped them all together and created something bigger than the sum of their individual parts. And again, that whole routine can just be one piece of a much larger complex adaptive system. So what other kinds of pieces do we have at our disposal? Other types of bricks that we might use to make up our CAS solution. You also have the concept of NMVS's built-in modeling system. Now, NMVS's modeling system can be expanded through the use of plugins, and those plugins can run either at the collection, at the moment that the collect data is being collected from devices, or at an update cycle. So there's a couple of ways to do it. But the whole concept with a plugin is to expand on NMVS's built-in modeling system and thresholding and expand it. Give you the ability to pull additional information. So now imagine, for example, having a script in opEvents that based on the results of perhaps an event, so a specific event occurs, a script runs, and that script then reconfigures a plugin. So it might change the way that NMVS is gathering information from a device or class of devices, or even just from a specific device. You might use that same kind of metaphor or pattern to change how often NMVS runs a collection on a device. So we have internal collections that can be built, or collection poll, what are called polling cycles. You might have a device on a standard default 5-minute polling cycle, so you're pulling performance information every 5 minutes from it. But based on a current, a specific event, or maybe an event priority, you say, gee, this event is important and it belongs to a device which is owned by a VIP customer. And so what I want to do is I want to, rather than collect performance data every 5 minutes, I now want to change that to every 1 minute. And so you might change your polling parameters for that one device, again, based on an event that's occurred and how it's being processed in opEvents. Lots and lots of different things that you can do here. Generally speaking, collections are done or checked and run every polling frequency depending on how they're set on that device. So you might adjust things like polling frequencies. You might use plugins to be able to expand the concept of what data is collected. So you might collect additional troubleshooting data. You might enable or disable different types of collections. So you might collect on IPSLA. You might collect on additional information about that device. Again, changing the way in response to an event that you're capturing data about that device. So back to a complex adaptive system. And I know I've talked about a lot of parts, and I've used the analogy of a Lego set. But if we come back to this example that we gave earlier, and we start looking at this concept really in detail. So we have this initial event that occurs. Each of these individual pieces, these actions, like determining a priority, that's one of those little pieces. It's part of an agent. It's something that could be called multiple times, depending on whether it's done as a script or as part of a policy action. It might be run once, or it might run multiple times, depending on what's happening. You can recalculate things like emails, creating tickets, pinging devices. And again, each of the results of each of these could be then also looked at and ascertained, and then other events could be called or created. A perfect example of that concept is right here, where the system calls opConfig and does an MTR, right? And that MTR, when it pulls back the results of the MTR, it's compared to the last results. And that change, that may raise a change, creating a new event. And so this line, this blue line at the top, this is entirely new event, separate from the dark blue one running down the middle. And so each of the events that are happening along this could be happening as parts of policy actions. They could be running as escalations on a time. So for example, you might say, we're going to determine the priority immediately. Then we're going to wait 5 minutes, and we're going to maybe collect another MTR. And if it hasn't changed, we're going to run an action that reroutes traffic. You may also go, again, another example here. Again, this dark blue line is a timeline. So time 0 at your left, the moment the event occurred, and then each of these events might be happening at different time periods. So these checks and balances could be happening as, again, event policies, which only escalate once, or an event policy might have called an escalation, and the escalation is running over time. And so, for example, putting the node in or running the priority, or creating an email, creating a ticket, that might happen 5 minutes after the event occurs. Running these troubleshooting pieces might happen at the same time or moments later. Checking the MTR might happen 10 minutes after the event occurs. Checking if the event's a service-related event, that might happen right off the bat. It could even happen earlier than the MTR. But you'll see, for example, that we've spawned another event, so another config change here, again from a test, and that one's used opConfig, and now it's running a whole other series of pieces here. So you'll notice there's an action here for rolling back a change. Meanwhile, if the main escalation line keeps going, the system may get to the point where it updates a website and marks a website that says, hey, we've got an outage in this region, and it might generate an email to dispatch field services to work on the device. And again, this can all happen automatically behind the scenes, or if an engineer starts looking into this and acknowledges the event, then event escalation stops. And your processing for your complex adaptive system ends at that moment, and then it begins reworking again on the next event. So many different options that are here. All of the pieces here in yellow, these are all pieces actually being done by opConfig. So the pieces in dark blue are comparisons being done by opEvents. The pieces in yellow are being assisted by opConfig, calls out to the opConfig CLI. So how do you build something? How do you actually start building a complex adaptive solution? Everything starts with the individual. Just like that termite nest, and there are termite nests that are 15, 20, 30 feet tall. They weren't built by one individual termite. They were built by a colony over years and years of activity. But that colony is built up of all of those individual agents or components, those termites. Just like that, that's how you build a CAS solution. You start by defining or identifying an individual event. You list the steps you take, troubleshooting and remediative, when that issue occurs. And I actually like to see this done in an interactive session, a group of engineers sitting in a room talking, arguing, whiteboarding, laying out things. Because different engineers would approach the same problem differently. What automated actions can and should be carried out? Data collection, remediation, etc. Do you really want to reboot a device? Do you really want to push a device configuration back? Are there any situations you wouldn't want to push a device's configuration back to it? And then identify things like who needs to be contacted, when do they need to be contacted, how often do they need to be contacted. Under what circumstances? How do they need to be contacted? Do they get a phone call? Do they get a pager? Do they get an SMS text message? Do you want to use a third-party process like PagerDuty to push an event out to, and then have that figure out what time of day and who's on call, and phone, dial a phone and read an event to someone? So lots of different options to work there. And then what should happen over time if the event is not acknowledged? And then what you do is you lay out these things over time on a timeline. So you just take a whiteboard and create a timeline across it. So just as this is a timeline, and you can mark different times on this, you'll want to do the exact same thing for every event. And if you start with the smallest, simplest events first, then you'll end up creating several little paths like this one, which might only have a couple of steps in it. But what you'll find is that as you create responses to simple events first, when you start looking at more complex events, you'll find opportunities to test for a result, which may then result in calling those simpler responses, just as these ones called the smaller responses for a general config change and a change in the MTR. I know this is a bit of a complex leap for everyone. What I want you to do is take a few minutes, take some time, sit down. I like to use a whiteboard. I like to do it on a large whiteboard and start mapping these pieces out. This kind of an exercise is a great part of what we do in doing implementation and implementation training and doing user training for opEvents as well, is walking through these types of solutions, these types of opportunities, and then creating responses that are very, very specific to each client individually, and that can work together to create a really robust, again, complex adaptive system for their event response. So that concludes today's seminar. I want to thank you all very much for your time today. Again, we'll be following up with an email shortly with links to this recording. If you're here today, you can download the PDF live from the handouts panel on the GoToWebinar chat window. And when I close out, there will be a brief poll for everyone. Please answer to the best of your abilities. If you have any questions, please feel free to email me at markh@opmantek.com. That does come directly to me. That is my live email address. It's not a bot. At least I don't think I am. And that is my live cell phone number. So feel free to give me a call if you have questions as well. Happy to help you out with a proof of concept and help you implement your own complex adaptive solution. Thank you.